question is find the acceleration A1, A2 and A3 of 3 blocks shown in figure if horizontal force 10 Newton is applied on the 2 kg block first. Okay, so if it is applied on 2 kg block, so what we are going to do is first we will start with, if it is applied on the 2 kg block, then we will first consider the combined motion. Okay, and we will write the maximum friction forces. So what will be maximum friction force on the 3 objects? So what will be maximum friction force here, maximum friction force here? So here maximum friction force is, suppose we write F1 max. F1 max will be how much? 2 kg, normal is 20 Newton into 0.2. So 20 Newton into 0.2, that is 4 Newton. Okay. Similarly, F2 max. F2 max is how much? 2 kg plus 3 kg. 5 kg is normal force here on the 3 kg, 7 kg surface. So 5 kg. 5 kg means 50 Newton. 50 Newton into 0.3. So 50 Newton into 0.3, that is coming how much? 50 Newton into 0.3. So that is coming 15 Newton. Okay, so this much we are getting. So these are the two maximum friction forces. Now if we apply the force on the 2 kg object. So if F applied on 2 kg object, we assume the joint motion first. If it is applied on the 2 kg, okay, 10 Newton force. So first we consider, assume combined motion. So what will be acceleration? It will be 10 Newton divided by 2 kg plus 3 kg plus 7 kg. Okay, so 10 by 12. So that is coming 5 by 6 meter per second square. So this is the acceleration. Okay, so this is the acceleration of the whole system. Now, to have this acceleration, if you consider this lower two objects together, if you consider 3 kg and 7 kg together and write the try to find the friction force here. So if you pull it here, the friction will act F1 in this direction and the F1 will act in forward direction. Okay, so F1 here, how much will be the F1 on these two objects? The F1 is the applied force on the two objects, because F1 is the only external force on the lower two systems. So F1 will be so F1 will be 3 kg plus 7 kg, the masses, into acceleration, that is 5 by 6. So how much it will be? 10 into 5 by 6. So 10 into 5 by 6. So how much it is? 50 by 6. Okay. So we are getting how much? 10 into 50, 50 by 6. So how much is this? This 8.33. So the friction force which we are getting is 8.33, and that is more than the maximum allowed friction here. So sliding will start. So we can say sliding will start. Sliding will start at the upper surface. Since F1 is greater than F1 max, sliding starts. So if sliding starts, it means A1 will be equal to, now how much? The applied force is how much? 10 Newton. 10 Newton minus the maximum friction is 4 Newton. F1 max divided by the mass, that is 2 kg. So that will be 10 minus F1 max is 4 by 2, so that is 3 meter per second square. Okay, this is one thing. Now second is for the lower objects, how much will be acceleration? So now consider 3 and 7 together. 3 and 7 kg together, if you consider 3 and 7 kg together, then what will be the acceleration? The A2 and A3. The A2 equal to A3, we can write as, this is A1. We can write, since the friction force is 4 Newton only. So 4 Newton divided by total masses. So how much are the masses? 3 plus 7 kg. So that is 4 by 10 kg. 4 by 10 meter per second square. 0.2 meter per second square. So upper object will accelerate with 3 meter per second square, and the lower two objects will accelerate with this. But now if you can see, so there can be sliding at the lower surface as well, between 3 and 7. But that is not possible. Why that is not possible? Because the applied friction here now is 4 Newton. The applied force on 3 kg is 4 Newton. And the applied force on 3 kg is 4 Newton. And on the 7 kg, if you see, on the 3 and 7 kg interface, the force is 15 Newton. Okay. Between 2 and 3 kg, it is between 2 and 3 kg, how much is this? This is applied is 4 Newton. The maximum friction is acting, and between 3 and 7, the maximum which can act is 15. So applied force, the friction between them cannot be greater than 4 Newton. So it will always be less than 15 Newton. So they will always try move together. Between 3 and 7, we can easily say that they are not going to slide because the friction between them is very large, 15 Newton, and the applied force on them is only 4 Newton. So they cannot slide on each other. So in this case, we have got the three acceleration. Now, in second case, it says that the applied force is on the middle one. Okay, so now we will write the same thing. We will do for the middle object. So this one is there and this one. If we apply on the middle one, 10 Newton. Okay, if you apply on the middle one, the F1 max and F2 max we have already calculated. That was how much? In this case, it was 4 Newton, and in this case, it was 15 Newton. Okay. So if you pull it, the common acceleration for combined motion, for combined M1, M2, 2 kg, 3 kg, and 7 kg. For combined motion, the acceleration will be how much? That will be 10 Newton divided by 2 plus 3 plus 7 kg. That is 10 by 12 meter per second square, or 5 by 6 meter per second square. Okay. So this is the common acceleration. Now we will see that whether with this acceleration they are going to slide or not. So on upper object, you see how the friction are acting. F1 is acting here because we are applying force on the middle one. F1 is acting here, F2 is acting here. And on the lower one, F2 will act forward, which will pull the lower object, and on the upper one, F2 will act forward, which will pull the uppermost object. Okay. So if we apply the force of friction on, if you apply external force on the middle one, the backward friction will act from the upper surface like this, and for the lower surface like this. And on the upper object, oh sorry, this is F1, sorry, this is F1 and this is F2. So F1 will act in forward direction. So, and F2 will act on the lower. So what is happening? Suppose we are having 3 books over each other. We are trying to pull the middle one. So if you pull the middle one, it will try to pull both the upper one and the lower one because of the friction. Okay, so that is the thing happening. So now we will check. So how is the F1? So F1 is trying to move the upper object. So F1 will be equal to, this is for 2 kg. F1 will be equal to the 2 kg into acceleration 5 by 6. So that is coming 10 by 6. So that is how much? 10 by 6 means 1.67 Newton. So this is less. F1 is less than F1 max. So this is possible. The upper one will not slide. The 2 kg does not slide. On 3 kg. Okay. Now lower one we will check. So F2. F2, if you check, how much is this? If you check F2 is going to be how much? 2 kg was there. So F2 is for 7 kg into 5 by 6 for 7 kg. Okay, so it will be how much? 35 by 6. So how much it is? If we have 35 by 6, we can write 5.8, whatever. But this is less than. See, this is less than the F2 max because F2 max was 15 Newton. F2 max was how much? 15 Newton. It is less than that. So the lower one will also not slide. The 7 kg does not slide on the 3 kg. 7 kg does not slide on 3 kg. Okay, so we can write this. So all the three will move together. So the A equal to A1 equal to A2 equal to A3 is 5 by 6 meter per second square. So this much we are going to get. Okay, so this was when we applied the force on the middle one. Now we will see for the lower one. If we apply the same force on the lower one, if we have like this, if we apply on the lower one, 10 Newton. So first we are going to do the common acceleration, that will be 5 by 6. Okay, and now we have to check for joint combined motion. For combined motion, okay, now how is the friction acting? So F2 is acting here. So F2 will act in forward direction. This F2 is trying to pull whole upper system. Okay, so this F2 we need to check, and this F2 will be there. So the upper object will be pulled due to F1, and F1 will act in backward direction here. Okay, so for, see, F2 is trying to pull both the objects. So for 2 kg and 3 kg combined, if you see for 2 kg and 3 kg combined, the force will be F2 will be equal to, the F2 will be equal to how much? The masses of two objects, the 2 kg and 3 kg, 2 kg and 3 kg, 2 kg and 3 kg masses into acceleration. So acceleration is how much? 5 by 6. So how much we are getting? That is 25 by 6. So how much is this? 4 point something. So whatever, 4.1 by 6, 1.6, whatever we get. So it is less than, F2 is less than F2 max. So if it is less than, so these two will move together. So there will be no sliding at this surface, no sliding at 3 kg and 7 kg interface. Okay, and then upper one we can check, but we can see that this is very small actually, 4 Newton, and the upper one maximum is 4, this is nearly 4 Newton, so there will be no sliding. So we can check that, but no need to do that actually. So total acceleration is 5 by 6, so we can check for, if you check for, since there is no sliding at this, so we can check separately for the upper object. For 2 kg if we write, there will be F1 equal to 2 kg into 5 by 6. So how much we are getting? 10 by 6. That is how much? 10 by 6 is 1.67. So this is also less than F1 max. So no sliding at upper surface as well. No sliding at 2 kg and 3 kg interface. Okay, so all three will move together. A1 equal to A2 equal to A3 equal to A, that is 5 by 6 meter per second square. Okay, so what we have got final. In second and third case, the acceleration is 5 by 6 meter per second square, and in the first case, there is sliding occurs. There is sliding, and the upper one will move with this acceleration, while the lower one will move, 3 and 7 will move with this acceleration.